All right, y'all, let's do dilations. Dilations is a transformation that changes the shape size. So that size either gets bigger or smaller, or enlarged or reduced if we want to use the fancy terms, which we totally do want to use the fancy terms. Let me show you some more fancy terms. So here's the image. No, sorry, here's the pre-image. Gosh, I know how to do this. We're fine. If I want to perform a dilation on paper, which I'm not expecting you to do, but if you're doing your notes along with me, you might get grumpy at me for not showing you how to do this. What you're basically going to do is you're going to take, this is your center of the dilation. You're just going to draw through all the points. It makes this kind of weird. Oh, snaps. Those are the same. I'll just do it like maybe here. Okay, so draw through all the points and then double the distance. So if this is like an inch, go another inch. This is an inch, go another inch. That's an inch, it'd be like right here. So that's how you make a bigger shape. All the things we're going to do today are centered around the origin. So it won't be this crazy, but this is the idea. So this is the image and that's the pre-image, which we know that vocab from last time. You haven't watched the last video yet? By golly, go do it. You need to. Otherwise, this won't make any sense. Okay, so this is called the center of the dilation. And then there's this thing called a scale factor. Okay, I'm fine. The scale factor is K. Now, K is any length divided by the other length. So let me show you what I mean. If this length here is A from P to Q, and this length here is B from P to Q, then K would equal whatever B divided by A is. In this case, because I said to go twice as far, it would be 2. Right? So if this is half as long as this is, or if these are equal lengths, I mean, right? If this much and this much are equal, then this is a double. It's times 2. It's also why some people feel so freaked out when something's like 200% of the original price. That just means it got doubled. It's times itself, or it's 2 of them. Okay, let me show you something pretty cool. This is a dozen list activity I found. We're not going to do it because it's like 12 sides long and they're kind of thick. But if I move the center dilation around, it changes where the shape is, but it doesn't change its size really, right? This is still double the normal size. And if the center dilation is one of the points, then it gets bigger from that point. But notice that it is moving it around. So dilations don't just change the size, they also change the shape. But the important thing to remember is that it does change its size, right? So this red shape is bigger than the blue shape. This is the image and this is the pre-image. We also can do it smaller, right? So if the scale factor is bigger than 1, like if it's 2 or 3 or 4 or even 1.5, that's an enlargement. And if it's smaller than 1, if it's a half or 3/4 or something, that's a reduction. So I just wrote that over in the notes for you. K is more than 1's an enlargement. If it's less than 1, it's a reduction. Which those are words that mean that, right? If something gets bigger, it's being enlarged. If something gets smaller, it's being reduced. Don't worry too much about these words, but I did want to point them out for you. All right, now if C, which is the center dilation, I didn't add that the first time. Oops. If C is the origin, we can cheat a little bit. We can do a transformation rule where we go x, y, x times k, and y times k, or them both multiplied by the scale factor. That's an easier way to do it. What if it's not, you ask me? That's a great question. Then you just kind of find the distance. You don't have to find the distance like we've been finding the distance, with the whole distance formula and blah, blah, blah. But you can kind of eyeball it at that point. So if it's like three sideways squares away, then go 3 sideways squares more. So don't worry too much about that. I'm pretty sure all the homework I'm going to give you is from the center anyways, or from the origin. So you really don't need to stress about it. If it's the other case is that the center is one of the points. In that case, if it's right here, R and R prime will be the same. Let me show you on that thing from earlier. So if this is the center, right, then it's overlapping. R and R prime are the same. Does that help or hurt? I don't know. Okay, there we go. So the center dilation is on top of it, then it's the same point for both of the shapes. You know, like you do. So anyways, if this is all you need, you're good. Be free. I'm going to do one example with like an actual graph so that way you get the idea, but really that's all the information you needed was right there. So let's do one example though. You can stick around or you can leave. Peace out. Have a good weekend. Bye. All right. So I'm just making this up because there's literally 4 problems in your book and I'm probably going to use all of them. So I don't want to use those ones. So I have this cute little triangle here. For some reason, y'all, I didn't know this. The book and Desmos both use blue as the original and red as the new image. That's super weird. I don't know why that is. Okay, so we're going to double all of these lengths. And it doesn't tell me the center, so I can assume the center is at 0, 0. If it doesn't tell me, I'm just going to assume. I know makes an angle side out of you and me, but it's fine. Okay, so basically what I'm going to do is I'm just going to take all of these numbers and multiply them by 2. 2 for here, okay? So new A will be at 2, 6. Okay, new B will be at 4, 8. That's fine. And then new C will be at 8, 2. Oh no, 2, 3, 4, 5, 6, 7, 8, 2. So then that's my new image. Do I have to do this in red? No. I don't need to. You don't need to. Don't stress about color, okay? Especially if you're colorblind. This will be more fun for you. But that's how that works. So here's my center. I stretched everything out. All of these lengths are doubled, by the way. If I actually found this length, I would multiply it by 2 to find that length. Everything's doubled. I would do the same exact math if this was like a half. I would hate it because I did the 3, but I would do the same math if it was 120%. I would multiply it by 1.2. Okay, it's fine. Don't worry about it. Don't stress about it. That's it. Tune in next week for when we actually do more than one thing at once. But right now, I just want you to focus on dilations. Next time, what we're going to do is we're going to do all of the isometries and the dilations, all 4 different things you can do. Stretch, flip, rotate, move, and we're going to do them all. Not all, but you know, we're going to do them all. Okay, bye!